The molecule that enzymes bond to is called the substrate, which is this, and this is the enzyme. The molecule that is created at the end of the reaction is called the product. The substrate bonds to a small area of the enzyme, which is the active site, so where this bonds, and then it forms around it to form an active fit. And so when the enzyme bonds to the substrate, we call this the enzyme-substrate complex. Once the reaction is done, the enzyme releases the product and is ready to bond from that substrate. And it's a lock and key mechanism where the substrate is the lock and the enzyme is the key, so only the enzyme with the structure that fits perfectly into the shape, like this, can act on the substrate, hence specific enzymes act on specific substrates. The enzymes break down the substrate and products and produces its products, allowing the enzyme to catalyze another substrate, allowing it to keep going through the cycle. Enzymes aren't affected by the substrate or by the reactions and are left unchanged, and the step with the lowest velocity determines the rate of reaction. The allosteric site on an enzyme is where a molecule like this that is not the enzyme bonds to the enzyme, causing the enzyme to change shape and lose its ability to bond, so it changes the shape of like the active site. Coenzymes are organic molecules that are required by certain enzymes to help during reactions. A competitive form of enzyme inhibition is where the binding of the inhibitor to the active site on the enzyme prevents the binding of the substrate. So like this would go right here, preventing this to get in the active site. And then non-competitive inhibition occurs when the inhibitor reduces activity of the enzyme and binds to the enzyme whether it is or not has already bonded to the substrate. Enzymes always end in ase and are named after the substrate. And so with non-competitive, like this would connect right here, changing the active site, allowing this to not be able to bind.